Hello students, and welcome to today's lesson on scale drawings and models. In today's lesson we are going to be looking at how scale can be applied to drawings and models in order to find a missing or actual dimension. Our essential questions for today are: what are scale drawings and models, and how can we use scale to find an object's actual dimensions? To review our vocabulary learned in the last lesson, a scale drawing is a two-dimensional drawing that accurately represents an object. In the previous lesson, we learned that they are mathematically similar to each other. Similarly, a scale model is a three-dimensional structure that accurately represents an object. So the difference between a scale drawing and a scale model is that a scale drawing is two-dimensional, having only length and width, whereas a scale model has that length and width, but also has depth, a third dimension. Like a scale drawing, a scale model is mathematically similar to the actual object. In the previous lesson, we learned that there are three types of scale that can be used when we're accurately representing an object. Two of those change the size of the actual object. A reduction is a scaled object smaller than the actual object. For instance, if we create a model of the Statue of Liberty, it's going to be a reduction because what we create is smaller than the actual object. The opposite is an enlargement. An enlargement is a scaled object larger than the actual object. For instance, if for science class Mr. Coons has you draw a cell, you are drawing an enlargement because your drawing is larger than the actual object. The other type does not change the size. A preservation keeps the scaled object the same size as the actual object. So for instance, if you draw a picture of your iPod the same size as your iPod, then it's a preservation of that object. It is the same size as the actual object. Scaled items can be used for all kinds of things, such as blueprints, which is a type of scale drawing. For manufacturing prototype cars, they may make a scale model of the car before they actually mass produce it, or for individual needs such as abstract art. Today I'm going to show you a really neat way that an abstract artist named Stan Hurd uses proportions and uses scale drawings and models to create a really awesome product. Stan Hurd is a crop artist and a farmer. He has created works of art as large as 160 acres. That's huge. That's fields big. He first creates scale drawings of each piece and then uses proportions to determine the actual lengths of the parts that make up each art piece. Here's an example of his work. This is a picture all made out of crops. You can see that it's in a big field. Here's another one of Stan Hurd's works. Before he creates something like this, he creates a scale drawing of it. And on his drawing, 2-inch squares represent 100-foot squares on the field. So you can see that he's making it 50 times larger. Plus, it's a difference of units. So he's enlarging that drawing within the field. Here is one field drawing that he made for Santana Hurd's first earthwork. Kawana Chief Santana was an important participant in the historical Medicine Lodge Peace Treaty of 1867 and a symbol of Indian resistance to European encroachment. So you can see that he has meaning, and he's being portrayed in this field within the dirt that he, tended during that time. Like scale drawings, like we just talked about, scale models involve scale as well. Do you know what the #1 scale model that exists is? You probably have them in your house somewhere. Matchbox cars. Matchbox cars have a scale, a ratio that describes their size and the size of this car that they are mimicked from. Do you know what that scale is? The scale is 1 to 64. If you look at your Matchbox cars at home, you'll find this somewhere either on the box or on the bottom of the car. And what that means is, for every 1 inch that model car is, that it's 64 inches in real life. Remember, scale is a ratio of the scaled size to the actual size. So let's look at how we can use scale to find a size, either on a scaled item or the real size. Now remember, scale is a ratio that describes the scaled size to the actual size. Now, scaled size is what it would look like on your scale drawing. And if you read this problem, it says the length of the object on a scale drawing is 3.5 inches. That means that we need to put the 3.5 inches in the numerator because that is the scaled size. So I write 3.5 over. Now it tells us that the scale, we know this is a full ratio because a scale describes two things. The scale is 1 inch to 12 feet. And if you look at the question, it says, what is the actual length of the object? So what is the actual length? Well, the actual length we don't know, so we're going to put an X there. Now, we know that since these are scaled drawings, that these are equal in value. 3.5 times 12, 3.5 times 12 is 42, so that equals 42. 1 times x makes 1x. Some of you know that 1x is the same as x, but if you didn't recognize that, you would just need to divide each side by 1 to get x equals 42. So the length of the actual object would be 42, and since this was 3.5 inches, then this unknown amount would be in feet, because we need consistent relationships. Inches to feet, inches to feet. So the actual object is 42 feet in size, in length. Let's try another example. You are using a 1/4 inch. I know that 1/4 of an inch is 0.25, and if you didn't know that, you could type in your calculator 1 divided by 4. So you are using a 1/4 inch, which is 0.25 inch, to 1 foot scale. That is our scale, or our ratio of the scaled size to the actual size. So when we're talking about scaled size, we're going to put that in the numerator. So we're going to put 0.25 in the numerator over 1 foot. And I like to label my parts so that I remember what I'm working with. Excuse the handwriting. I'm having difficulty with the technology on my side. So that's 0.25 inches. I'm going to have to write with the mouse, so it might take me a couple more minutes. It says you want to draw a wall that in real life is 12 feet. So you notice it says real life 12 feet tall. Real life is an actual size, so we're going to put that on the bottom. 12 feet. How tall should the wall be in your scale drawing? So we're looking for the scale drawing. That's why our x is going to be in the numerator. So 0.25 times 12 is 4. No, is 3. Sorry. X times 1 makes 1x, or just x. So x equals 3. So in our drawing, look at our units. Inch to feet, so it's going to be inch to feet. Our wall should be 3 inches tall. That's our final answer, 3 inches. Let's say that for art class, you're creating a model of a person. A person is a real object that's 62 inches tall. So I know that it's going to be over 62 inches because the actual side always goes in the denominator when we're talking about scaled items. It says your scale is 2 inches is 15 inches. So I'm going to put equals 2 inches to 15 inches. 2 times 62 is 124. I need an x in my numerator because I'm looking for how tall the model will be, and the model is always the scaled object, or the scaled size. So x times 15 makes 15x. This creates a one-step equation. Divide each side by 15, and we get 124 divided by 15, which is 8.26. We will go with 8.3 inches tall. So for our model, if we are truly modeling the way that this person exists, our model would have to be 8.3 inches for this scale. Let's try one more example. A model of a house is 18 inches tall. So it's the model that's 18 inches. So 18 is going to go in the numerator because that is the scaled size. And was made using a scale of 2 inches is 3 feet. So that's our other ratio. 2 inches is 3 feet. It says, what is the height of the, I should say actual house. Fix that on your paper. What is the height of the actual house? So we're putting x on the bottom because we're looking for the actual size. 18 times 3 makes 54. If you didn't know that, you could do it on the calculator. 2 times x makes 2x. So 2x is equal to 54. If we divide each side by 2, we see that x is equal to 27. Look at the way the units are, inches to feet, inches to feet. So our unknown is measured in feet, so it'll be 27 feet. The actual house is 27 feet tall. You have 2 practice problems to work on, which are located at the end of your notes. To summarize, scale drawings and scale models are both mathematically similar to an actual object. The only difference is that scale drawings are 2-dimensional and scale models are 3-dimensional. Because they are mathematically similar, we can create ratios to solve for unknown sizes.